Hello everyone, and in this video we're going to be looking at question 5 of the Stage 2 Specialist Mathematics SACE exam from 2012. And what we're going to be looking at in this question is the factor and remainder theorem and how we can solve a few questions associated with that. It's quite a simple question, nice 5 marks spread over 3 sub-questions. So let's go ahead and have a look at what we're given here. So we have a cubic polynomial, which is f of x equals x to the 3 plus ax plus b, when we know that a and b are both constants. And we're given a factor. X plus 1 is known to be a factor of f of x. And we need to show that b take a equals 1 using this information. Well, x plus 1 is a factor. Therefore, based on the factor theorem, we know that the f of negative 1 is equal to 0. Remember, it's always opposite sign there, because what we really have when we have a factor is x plus 1 equals 0. When we rearrange that for x, we have x equal to negative 1. So when x equals negative 1, the f of negative 1 is going to be 0 because of that factor condition. That, in essence, is a factor theorem. It's really simple to apply. Once you know it, it's just a matter of recognizing that, and hey presto, the rest just falls out nice and simple. So the f of negative 1 equals negative 1 to the power of 3 plus a to, multiplied by negative 1 plus b, and all of that is going to equal 0. Now we have negative 1 times negative 1 times negative 1. It's going to be negative 1. We take a from that, then we add b, we get 0. So we move that 1 to the other side, and we get b take a equals 1. As we were asked to show. So we've got that, and we've got our first 2 marks of this simple 5-mark question. So now it's time to look at B. And B, we're looking at what happens when we have another condition here. So what happens is we have the f of x being divided by x plus 2, and we get from that that the remainder is equal to 6. And we need to show that b take 2a is equal to 14. Well, we can use the remainder theorem. So again, very similar to the factor theorem, the remainder theorem, what we essentially do is we swap the sign, and we have that the p, or f, of negative 2 is equal to 6. So then what we do using this is we say, well, okay, we have the f of negative 2, and it's going to be negative 2 to the power of 3. Take 2a plus b equals 6. We're just substituting in negative 2 into our function f of x there. Right, and we know that's equal to 6 because of the remainder theorem, so we can rely on this condition. That should technically be an f there, I'm sorry about that, but it's equal to 6, and we rearrange like we did before, but in this time what we're doing is we're bringing the 8 over, so we're getting 14, and we end up with b take 2a is equal to 14. So again, it's just a matter of using the remainder theorem. We identify that condition, and after we've identified that condition, it's just algebra, and a really simple algebra too, and that's why we get a little mark there. So we're on to the last part. We're on the home stretch for question 5. Find a and b, and hence write f of x as a product of linear factors. Keyword there is linear. So we're going to find a quadratic factor first, and then from there we can find the linear factors. So this is where a bit of algebra comes into play. So b take a is equal to 1. We know that from before. That was the very first thing we're asked to find back in A of question 5. So therefore we can rearrange this such that b is a plus 1, or a plus 1 equals b. That's just rearranging it. So we've got one variable in terms of another, so we can substitute that in wherever there's a b in the next equation. Now remember that b take 2a was equal to 14. Well, hence a plus 1 take 2a is equal to 14, because we know that b is just a plus 1, and we just substitute that in. Very straightforward, very simple algebra. The thing I like about this question is once you've identified the conditions and you've got your head around it contextually, it's a very simple question, and you can get really good marks here really quickly, as opposed to other spec questions where you may have a bit more messy algebra and a bit more thinking. Here it's very straightforward, it's very logical. You just need to know the core concept. So from this we know that negative a is 13 just upon simplification, and therefore a is equal to negative 13. What we're just doing there is we're multiplying both sides by negative 1. Using our condition where b take a equals 1, we can then identify that b is going to be equal to negative 12. So we've found a and b, so we've done the first half of this question. Now the second half, write f of x as a product of linear factors. So we know now that f of x equals x to the 3, take 13x, take 12. We know this because before what we had was we had x to the 3 plus ax plus b, and we've identified a and b, so we just substitute them in. That's our f of x right there. So now, what we also know from the very first question, A, is we know that x plus 1 is a factor. Because x plus 1 is a factor, we've already got one of our linear factors here, and we're just worrying about a quadratic factor here. So we understand that we're going to have, obviously, 3 linear factors, because we've got a cubic polynomial here. So what we're doing now is we're identifying what to do with this linear factor. So now, what we're left over with, once we remove x plus 1 from this expression here, is we're going to have some x squared term, plus cx, and we know it's going to be x squared because we have x times x squared, that's going to be x cubed, and we know that the coefficient of that's 1, so we know that it's just going to be x times x squared to give us the x cubed, because x times x squared, that's the only way we're going to get that highest power there. All that's going to be equal to 0, but we know also that our constant, which is also brought by only the last 2 terms in our quadratic and linear factor, is going to be negative 12. So we know that that's going to be negative 12 there, because when we times it by 1, we're going to get negative 12. So really, it's just a matter of finding the value of c. So by considering this, we know that c plus 1 is going to be equal to 0. That's simply by just analysing the expansion there, because we know exactly what's going to happen. And consequently, we know that c is going to be equal to negative 1. So as a result, we end up with this quadratic here, x squared take x take 12. Then what happens is we can identify how to write this, and we can see that x take 4 and x plus 3 is suitable. And what we've hence done by doing this, and again, you can use your calculator if you want to use a polynomial root finder application, go ahead. But we can just put them in, but we know that it will factorize nicely into this form, and hence we got our product of linear factors. So that last little bit, you can do it a few different ways. That's a more conceptual way. At that point, you can technically just go, well, okay, I've got my cubic here, let's just put it in the calculator and get it done with. And for 2 marks, it's probably a good idea to do, because you know, 1 mark's going to be finding a and b, the other mark's just going to be stating the linear factors. So you can just go straight to your calculator, straight to the TI app, and you can immediately get what the values of x are, and then you just swap the signs, really. But this is a bit more of a conceptual way. So if you do have time and you're just doing this spec exam just for a bit of fun, you're not necessarily in a time rush, then do it this way. But elsewise, just use technology at that point. That's probably the best way to do it. Anyway, let's look at question 5. Really cool question. Thanks for watching this video. If you have any comments, leave them below.